Hi folks, welcome back and thanks for joining. Today we're going to do some candle testing, and this video was inspired by a subscriber who has begun making candles, and she wants to sell them in her store. And during discussions with her, I sort of let out the bag that I was a candle scientist for 11 years, and what I have tested is over 400,000 candles. And she has asked me to make a video on candle testing. She says that there is no good resource for that on YouTube, and I looked, and sure enough, there is not. So I'm going to begin a series of tests on these candles right here, and I'm going to go through the process with you, and I'm going to teach you how to test candles safely. And in doing so, we're going to gather valid data that can be used if your company grows to the point where you want to sell your candles to a big box store. The data and the safety protocols that you have in place are going to be required for these stores. So here's how we're going to get started. Alright, so let's get started. So if you'll notice, the candles are in a metal pan. These pans are capable of holding all of the wax should this container break. I also have these spaced out a bit. You don't want your candles too close together, because if they're close together, the heat from one will affect the melt pool of the other. A couple of very important things to have on hand is a stopwatch or a timer, because you're going to light these 10 seconds apart. Now the reason you're going to do that is because when you blow them out, you're going to use the stopwatch to record the time that the candle continues to smoke or emit a plume of smoke from the candle. The reason this is tested is because that plume can be reignited, which also is why you blow the candle out and you never dip the wick into the wax. Now there's a secondary reason you never dip the wick into the wax, and that is the mushroom or the carbon ball that forms on the wick will drop into the wax. If it's large enough, a 5mm carbon ball is a fail, because that can support a flame, and that would contribute to something called a secondary ignition. That would be a fail. So what I've done here is I've gone ahead and I've trimmed 4 of these, but I'm going to trim this one right here for you. Now before you begin testing, you want your candles to be in a room of about 70 degrees Fahrenheit for 24 hours for the wax to equilibrate. You're going to weigh the candle. Now, and then you're going to trim the wick. Now, one of the most ingenious methods I've seen for trimming the wick was the person that actually sent these candles to me. But I'm going to show you this. Trim length is critically important, so you want to make sure that you trim the wax the same length all of the time. Now, the reason I have these spacers here is because sometimes the wax forms a little dimple on top of the candle, rising up the wick, so that if you trim to the top of that dimple 1/4 inch, after you light the candle in 10 seconds, it's already longer. So I recommend that you use spacers to straddle the dimple before trimming. And here is the little ingenious little device. Now there are many candle wick trimmers out there on the market, but none that I ever found that I would use in my lab. And I actually made one by hand. Now this wick doesn't want to trim, but what I'm doing is I'm squeezing it to mark it, so that now, and that's snow falling off the roof, folks. So now what you want to do is you want to you've marked it, and now you're going to trim it. Just like that. Now it's ready to light. Now during testing, this is very important, okay? This is a container candle, and the container temperature can never exceed 140 degrees Fahrenheit at any time during the life of the candle. So you're going to be monitoring this. After I light these, I'm going to check the flame height at 5 minutes, And at 1 hour, I'm going to come back and I'm going to check the flame height again, and I'm going to look for any kind of smoking. If there's a constant stream of black smoke coming off the wick, that is a fail. So you just want to go ahead and extinguish that and stop testing on any candle that would do that. If the container temperature reaches 140 degrees at any time during the life of the candle, that is also a fail. It will not pass a safety standard for anyone. A couple of things. If a carbon ball forms larger than 5 millimeters, now what is 5 millimeters? It is slightly larger than 1/4 of an inch. That would also be a fail because, as I've also mentioned, that it can cause secondary ignition. So I'm going to go ahead and I'm going to light these 10 seconds apart. And again, the reason is because when I blow them out, I'm going to be recording the ember glow times. Okay, now I recommend that you use something like this, a long-handled lighter of some sort with a forced flame. And here we are. We're going to begin lighting now, okay? So, as soon as you touch, start your timer. Okay. 10 seconds apart. At 5 minutes, I'm going to come back and I'm going to measure flame heights. What I'm looking to see for a healthy flame is about 1 inch. And that would hold true for all candles except a small candle like a tea light. If the flame ever gets to 3 inches, that would be a fail. And at 5 minutes, we seem to be off to a good start. What I'm seeing here, there's the flames are all about 1 inch. This one's a little higher. That's not bad right now. I don't see any smoking. Now, speaking of smoking and the carbon black smoke that comes off the candle, another thing you want to do when you do your testing is to do this in a draft-free room. Now, some folks simply can't supply that. This one's beginning to smoke just a little bit. If you saw the little flickering flame, I would consider that a candidate for something called a draft screen. Now, that's not a hurricane lamp. A hurricane lamp will hold in the heat and it will give you an abnormally large melt pool that a customer would not see. For testing purposes, you want to use something like a door screen, aluminum door screen that you can just shape into a little tube to plop down over that. And that would prevent that from puffing. And if it continues to puff, then you know you have a candle system where the wick is simply too large for the wax. Okay, so that's 1 inch. That's 0.875. That's 3/4 of an inch. I have 1 inch. 875. And we have 1.5 inches. I'm going to continue to monitor the container temperatures at 1 hour, 2 hour, 3 hour, and at 4 hour. And I'm going to be looking for smoking, smoldering, plumes of smoke coming up, candle flames that exceed 3 inches, large carbon ball formations, things like this. So we're going to close that out right now. This looks just a little bit large, and I'm suspecting that this guy right here is simply not going to go too much farther. It's going to fail soon because of carbon formation or smoke pluming. You want to consider your customer. This is a paraffin wax, and a lot of smoking will generate something called indoor pollution. Okay, folks, it's been about 15 minutes, and I'm coming back on right now because I wanted to show you this candle right here, I've been watching it, monitoring it, and it is constantly wafting black smoke off of the wick. Now this is going to be a fail for me. I'm failing because of indoor air pollution. I don't know if you can see the black smoke rising off of the wick, but it's nearly constant. Now I know that I'm in a draft-free room, so it's not because of that. I also noticed that it is flickering to 1 3/4 inches high, so this wick is simply too large for this wax. Now this wax is these candles are made with no scent and no color. It is a straight pour paraffin blend. Now a blend is different than a fully refined wax. What they do is a fully refined wax has a higher melt point, so they will blend it with something called petrolatum to lower the melt temperature, which is desirable for a container candle. So I'm going to fail this candle here now. Now you want to be particular and be ready to fail a bad system. So that's a fail, but we still have 4 other options to go. And here we are at the 1 hour mark, and I'm going to take some measurements now. Now what I'll be looking for is sooting, smoking off at the top of the candle. I'll be checking container temperatures. I will be looking for carbon ball formation. Now if we'll notice this guy right here, this wick right here, it looks just a little bit large, and it is popping a few bits of carbon. However, I'm going to let this go for just a little bit longer, and the reason is this is what's called a curling wick, and that means it's not going to stay straight. It is actually going to curl just a little bit. Now if you will read the information that I'm providing, the lectures given by Micheal Faraday talks about the edge of the flame is 2700 degrees. Now this wick is designed to take that as an advantage. It's going to curl to the edge of the flame, where the extreme heat is going to continue to trim that wick so that the wick never grows too large. So that is the purpose of a curling wick, to get to the edge of the flame, where the edge of the flame is going to continue to burn off that wick so that it never gets too large. Alright folks, and here we are at the 2 hour mark. I've gone ahead and I've made my flame height measurements, and I've recorded any sooting, and now I'm adding another column here, because what we're exhibiting now are on a couple of the candles some carbon ball formations known as mushrooms. Now this guy right here at the 2 hour mark, he is constantly puffing. So at the 2 hour mark, this guy is going to be a fail. The flame height is not that high. The mushroom is not the reason for the fail. It's the constant stream of black sooting that gives me the reason to fail this particular wick right here at the 2 hour mark. Now if you notice, see, the flame licks a little bit, but they're doing it on the other candles as well. But these are not sooting. This guy is just a bit too much, so he's a fail. Now if you'll notice, even though this wick was designed to curl so that it can get to the edge of the flame where it can be trimmed off, it wasn't enough to, it didn't curl enough to make it all the way to the edge. So the wick length was simply growing too much. Okay, and I'll see you in an hour. Alright, so at the 3 hour mark, I'm going to take a moment before I begin my measurements and just confirm all along the edge of the container that it is below the 140 mark. And they are pretty much at room temperature plus a few degrees. So we're good. As long as they don't get above 140 degrees. You can also feel the edges yourself, and 140 would be a very uncomfortable, you would not be able to hold it at 140. So that's why they have set it, the limit to be that. So I have 1 inch, 1 inch. That's a fail, and that licked up to 1 1/4, and I always count the lick. A little bit of soot. No soot. And no soot. Carbon ball production is, it's going to be a 1 millimeter, and I marked down the largest ball. So all three, the largest carbon ball production at 3 hours is 1 millimeter, and that's quite acceptable. Okay, so we'll be back at 4 hours, and I'm going to extinguish these at the 4 hour mark. All right, folks, now we're coming up on the 4 hour mark, so I'm going to gather all of the ending data. Now, to begin with, I'm going to, as always, check the container temperature all around the edge. Make sure that nothing has exceeded 140. Okay, we're good there. So now I can continue gathering the data. Let's do a quick flame height. Okay, that is settled down to 875. That's about 7/8 of an inch. And pretty much the same thing here. Okay, that's a fail. So I'm going to move on to this last wick here. And it is 1 inch. Okay. We're sitting here. And it's a slight soot here. And here we have slight soot. Carbon ball formation. And we have a 3. And we have a 3. And we have a 2. Okay. So after I blow these out, of course, I'm going to take pool diameters after I let them cool a bit, and I'm going to weigh them. That's what these are here for. Now, if you recall, I lit these in 10-second intervals, and this is going to give me time to record amber glow times, and that's important. Now, anything over 10 seconds is a potential fail for most of the big box stores. So this is important data here. So what I'm going to do is I'm going to huff these out, and I'm going to hit the start, and we're going to go from there. And let me wait until I get right on my minute mark. And there we are. Okay, we have 0.07, 7 seconds. And we have 0.05 there. We're going to wait 10 seconds. And I'm using the clock on the computer to keep track of my 10-second intervals. And here we are. Okay, and that was 4 seconds. Now, while I have the camera pointed down, I want you to notice these pool diameters. They're rather small. Now, this is a first burn, and the first burn will be the smallest pool. Don't be concerned if your first burn is rather small. Continue to test. And the reason being is candles have something that's called a pool memory. And what that means is it will get to a certain size in the first 4 hours, but when you subsequently relight this for the second time and subsequent relights, that pool memory will grow and it will get to the initial pool in about 2 hours, and then after the 2 hours it will continue to work out. So don't be concerned about the small diameter at this time. Continue your testing. And on third burn, I have 2 more failures, and I'm going to let you see them here first, and then I'm going to move the camera so that we can discuss this just a little bit more. So I don't know if you can see, but this candle right here and this candle right here, they're going to be failures. And the reason is because they're constantly wafting black soot off of the candle. Now, there's a couple other things that are going on with these 2 candles. One is the flame height is gotten to 1.5 inches. Now, that's not particularly bad, except for a small candle like this. What that is doing is causing a container temperature fail. If I can get it just right. It jumped up to 160 before I could release the button, but as you can see, 150 is a fail. What that means is if you grab this candle, it's going to burn you. And of course, if it burns you, what you're going to do is you're going to let go. And that's going to cause you to spill your candle. That's why 140 is the absolute maximum. It won't shock you so much that you drop the candle. And the same thing is here. We're way beyond what we need to be. So these are quite dangerous, and so I'm going to fail these 2 today. So I'm going to stop the video here and blow them out, and we're going to discuss these candles just a little bit more as to why they failed. Okay, so I've moved the camera a little bit more closely so we can examine the reasons why these 2 candles are failing today. This third burn, it's nearly 2 hours in, and both are exhibiting near constant sooting. And I'm going to try to hold this so that you can get an idea of the amount of sooting. This is unacceptable because this is paraffin wax. This is a source of indoor air pollution, and it will not pass. Now, of course, I've already showed you, but the second reason is, and it's just as important, and that is the fact that we've exceeded 140 degrees Fahrenheit on the container temperatures, and that also is a safety failure. Okay, I'm going to blow these out so that we can look and examine the reasons why. Now, you want to be careful when you're using a curling wick inside a container candle. And the reason why, as you can see, is it has curled in that direction and it has moved the pool. So we have a ledge here and we're almost nearly melted there. And this is quite common for a curling wick inside a container. What that means is the cold air has come in here, gone across that flame and wafted up hot, bringing some cold and causing the soot to form right here on this ledge right here. Now that is the case for both of these wicks. They're both curling wicks. They've both generated a ledge, and they have brought the soot up one side of the container. This is quite common when you put a curling wick inside a container. And we're coming up on what I will wager is the last burn on this candle. So we're going to light it now. And I suspect that it may or may not make it the full 4 hours. But what I'll be looking for on its last burn is the container temperature. And to see if this candle system will self-extinguish at the end of life without cracking the container, and the ember glow time. Alright, so it has just expired and the ember glow time was about 5 seconds. The container temperature never really got that high. The burn lasted about an hour. So this is a successful test right here. Now if I hold this up very closely, you can see that the wick has completely consumed itself all the way down to the tab, and all that remains is a slight gray ash. That's a perfect test right there. The candle itself did very well. Minimal sooting during the entire life of the candle. This is a successful system. Now there's one more bit of data that you need to gather at the end of life on your candle, and it relates to candle safety and specifically secondary ignition. What I've done here is I have melted the candle down so that I can liquefy what's inside the container, because we're going to check one more thing. And we've discussed this before, and that is carbon ball formations. Let me move this and hold this candle up just a little bit closer so that you can see down inside. And what you're going to be looking for are carbon ball droppings inside the melted pool. This candle has none, so you can be assured that you have a safe candle system. Now there's a little bit of black floating on top of the wax, and what that is a little bit of soot that wafted up during burning, and it has melted. Now it's going to float on top. I see one carbon ball dropping of less than 1 millimeter that's laying on top of the tab. Take a photograph of this while it's in its melted state, and keep that photograph in your archives, and I'll explain why when I come back. Alright, so the reason why you want to test your candles from beginning to the end of life, and even melt it down at the very end, I don't want to alarm you, but if I do, that's okay too. But I do want to arm you with knowledge of litigation. The consumer, your customer, is awarded immediately without exception the expectation of safety. When they purchase your candle, they have been given the expectation that your candle is a perfectly safe candle. So that last photograph that we took of this proves that your testing system gave us a perfectly safe candle. So I hope this has been helpful to you, and I'm going to include a few documents in the links below that you can use to gather data, okay, along with a couple other things, a candle safety data sheet, a tips and tricks provided by the National Fire Safety Association, and a standard testing protocol that I've used myself for many years. I hope this has been helpful. And just remember now, candle safety is a very big deal. And if you like this video, please subscribe. And thanks for watching. Bye-bye.